Hello, everyone. Good afternoon. The authors and invited guests, welcome to Technical Session 11E. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event took place on the 17th of July in Goa, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Dr. Smita Agarwal, who is presently working as the HOD of Department of Information Technology of Jaipur Engineering College and Research Center, JECRC Jaipur. She's having more than 20 years of teaching experience. She has been the HOD for more than 10 plus years. She's a member of POS in Nirvan University and reviewer in the Journal of Soft Computing. We welcome you, ma'am. We'd be beginning with the papers now. Our first paper presenter, I'd like to call upon Arokia Raj S. with the paper titled An Automated Interview Question Generation Framework, Gen AI Agent. So if you're ready, then you may start with the presentation.
Hi, thanks. Hi all. Good morning. Good afternoon. I can share my screen, right?
Yes, sir.
Okay. Are you able to see my screen?
Yes, sir, it is visible.
Okay. Hi all, Arukiraj here. Thank you for being here today. I'm glad to introduce you to the automated interview generation framework, a cutting-edge AI tool powered by Gen AI. I have co-authors Dr. Amuda and Dr. Swaminathan, but I'll be presenting today. Okay, so let's begin by understanding the context behind our research. If you see in today's job market, a single job opportunity often attracts hundreds of applicants, sometimes thousands. However, a significant portion of them may not meet the basic qualification. So this puts immense pressure on recruiters, making the screening and interview process time consuming, biased, and inconsistent. To solve this challenge, we propose an automated interview generation framework, which is based on Gen AI, which aims to streamline and standardize candidate evaluation. So, as I said, the core of our solution is a Gen AI agent, which can dynamically generate interview questions based on role-specific skills and criteria. It helps in narrowing down the candidates by assessing their abilities through generated questions and an automated evaluation, which we will see. So from a technology standpoint, it's built based on OpenAI's GPT Turbo. From a natural language understanding and content generation perspective, LangChain is used for prompting, and we have also used Streamlit to have an user interface. So we believe what makes powerful this framework is the customizability, because recruiters or educators can specify the topic, the difficulty level, and then the question type, the number of questions, time constraints, so on and so forth. So overall, the framework doesn't just automate, it adds intelligence, personalization, and fairness to the recruitment process. So moving on, as I said, this is a Gen AI agent. And if you see based on our research, our observation, we found corporate job opening receives hundreds of application, and approximately 88% of those candidates are unqualified for the role. So these are all the major problems in the recruitments nowadays. One is high volume or overload. Recruiters simply don't have time to assess each application in depth, and bias, which means human interviewers sometimes may unintentionally allow personal preferences or judgments to influence the outcomes. And overall, it's a time consuming process. Again, to summarize from a technology perspective, yes, it's based on LLM. From an LLM integration perspective, we have used Crook API. LangChain is for prompting, and Streamlit for development. So overall, we have used 4 prompt strategies, a few short learning for aptitude questions, chain of thought prompting for coding problems, knowledge-based prompts for technical interviews, and adaptive graph of thought for behavioral assessment. So we believe our framework will be a game changer in terms of automated interview, which transforms the traditional hiring process into an efficient, unbiased, and intelligent pipeline, because the system dynamically generates interview questions based on the job role level, and during the assessment as well, based on the answers, it will assess the proficiency of the candidate, and the subsequent questions will be based on the level of answers what he or she is giving. And I also like to call out some of the similar work based on our literature review. We like to call out some of the similar work, what is happening. The first, if we take multimodal interview analysis, it's an agent which combines voice and NLP to give holistic feedback, but then it relies heavily on input quality. If you take in case of a competency-based interview bot, it uses the behavioral event interview method and NLP to assess core competencies, but it requires large training data sets. And we do have a bot for AI in English learning. It just boosts job readiness by improving communication and body language useful in intention program, but it lacks true human interaction. And finally, if you take, there is an interview bot, AI chat bot based on GPT and LangChain. It enables adaptive technical and HR interviews, but often with real-time feedback, but it has scalability and bias issues as well. So these studies also motivated us to come up with an automated interview bot that can be scalable, more intelligent, and customizable. Moving on, let me summarize the overall framework and the methodology. So the overall framework is based on behavioral event interview method, and it uses NLP and machine learning to analyze candidate responses and determine the competency levels. As if we see, the interview process is structured into three stages, like introduction, competency assessment, and validation. So during the assessment, the candidate responses are evaluated using techniques like the typical text analysis, tokenization, etc. We assess candidates in four stages, right? Each aligned with a specific prompting strategy. So the stages we have are aptitude, coding, technical, behavioral. In case of aptitude, we are using few shot prompting, basically to test the logical and analytical thinking. For coding, we are using chain of thought prompting, which will break down the problems into logical steps for better clarity. For technical evaluation, like the programming, we are using knowledge-based prompting to verify the subject matter expertise. And in case of behavioral stage, we are using the EGOT prompting, which dynamically adjusts follow-up question based on candidate's answer. And the evaluation is based on a technique called rubric scoring. So which it always have three dimension. One is correctness, assess how correct and closer the response is, the depth, the thoroughness of the answer, and last one is the relevance. So based on these aspects, a scaling will be given from a score will be given from a scale of 1 to 4. Then the system finally calculates this to a binary score based on the threshold, whether for a particular question a candidate is pass or fail. So this overall, this method streamlines and also make evaluations more objective, data driven, and scalable for large candidate pools as well. So just like to showcase some of the output, right? So that this is how, if you take an aptitude question, these are the user interface will be there. There will be a question asked to the candidate, and in the right side, what you're saying is this is an aptitude question, and then the answer given by the candidate. Based on the answer, the prompt will uh, assess and derive the scoring. In this case, the candidate got 10 out of 12. Actually, we have this is still in the test environment. We have not implemented in any corporate as such. We are in the process of doing it, but we have taken data set from the university itself, and we tested with different candidates in parallel with an actual interview and through the bot. In this case, the rubric score is 10 out of 12, which means the candidate has passed the question. Similarly, one more, just another example. If you see, this is more of a technical question for a data analyst role. In this case, based on the candidate's answer, the scoring is 12 out of 12. So the candidate is passed. So similarly, the bot will keep generating the questions based on the number of questions what we are setting, the complexity and the proficiency level. It will keep generating and finally give the assessment. So overall, to conclude, this application is designed to serve both recruitment process, be it a corporate or an educational perspective, by generalizing the personalized quizzes based on the skill level and topic. So as I said, users can customize everything from question type. It can like be it a MCQ or true or false, open-ended to the difficulty level. It's built with an user-centric design, supporting all learners at all stages, beginner to advanced, which also helping employers assess candidates more effectively. And then the tech side, for now, we are using mostly on the open whatever open source we have. So there can be lots of improvements we can still made, and we are in the process of doing it. And from an overall benefit perspective, it's fast, scalable, and high quality experience, um, making it a powerful tool both for learning and hiring. So with that, let me conclude my session. Questions.
Thank you, sir. Our session chair is having an issue with the mic, so she'll be asking questions in the chat. Ma'am, that's okay, entirely okay. Would you like to ask any question to the presenter, or shall we continue with the next presentation, ma'am? No question. Okay, so we'll be proceeding with our next paper presenter. I'd like to
Thank you.
ask for Mohit Garg with the paper titled Anomaly Detection in Lungs Using Deep Learning. Sir, if you're ready, then you may start with the presentation.
Yes, ma'am. Can I just get
Yeah,
a minute to have a small setup?
sure, sir. So also, if it takes a bit of time for you, then we can proceed with the next presentation and you can present later on in the session, if that's all right.
No, ma'am, I'm just done. That's no
Okay,
need.
okay.
Yes, ma'am. Is my screen visible?
Yes, sir, it is visible.
Okay, so good afternoon, everybody. So the topic of our research paper is anomaly detection in lugs using deep learning, and we are affiliated to Vishwakarma Institute of Technology. And these are all the my colleagues which we work on this research from the institute itself as a part of our annual project named EDI. So continuing with the presentation, so the first thing which we took was a deep research on a topic, which is to help the current situation of doctors. So one thing which we emphasized on is at the end, doctors are indeed humans. We can't expect them to work with 100% accuracy 24 hours a day and 7 days a week. So it is just a helping hand. Our topic is just a helping hand to our current doctors, to current researchers. So what the current flow of the project is, it will be a helping hand to our doctors to analyze the X-rays specifically in the portion of chest. So we have focused specifically on the portion of the chest mainly, and that too because the number of cases for the and that too for the number of cases have been extremely high for an incompetency in the field of this paper. Because the thing what happens is it uh, even due to a minute 0.21% of the error, the X-ray and its output can fail, and it can even lead to severe damage to the patient, for example, and it can even cause sometimes death. So the main issue is there isn't any supportive thing which can help doctor to actually analyze whether its outcome which he has assumed or which he has came up with his studies is actually correct or not. So it is a process in the similar way. So our main objective was to define and to explain the importance of detecting anomalies in lung images for early diagnosis of disease. we are not saying ki we should replace this with the doctors, but it should help in as a helping hand to a doctor. So there have been like current researches in the field. For if I can just go, there have been done a lot of current research in the field, but the only thing was the data set and the quality of the data set. So what we did was we did first is the pre-processing of the data. So this is the exact data set which you use. It has over 1 lakhs of images. So the main thing was the pre-processing of the data, and there have been number of studies on the same data set. But actually, what happened was either they were using a DL model DenseNet, or either they were using other DL models. So they were getting an accuracy of, as you can see, 0.7 to zero point 0.8. But our actually point was at it is actually related to the medical field. So accuracy should be the utmost priority. So what we did, we combined all the researches and we came up with a new solution, that is to combine all the DL models and to give a final accurate solution which will be actually helping to the end user or the doctors. So we came up with an idea to combine the DenseNet and the UNet and the GradCam, which wasn't used as an integrated system, and it was used parallelly by the other researchers. So what we did, if an image, for example, if this is an image, okay, there is some image generation issue here. Okay, if this is an image, what it will do, it will be first classified by DenseNet, then it will be, first it will be segmented at the DenseNet, and then it will be classified into its portion. This is by unit. And then with the help of GradCam, as you can see in the image, you can even see the portion which has some anomaly or which has some issue. So what it does is, first the segmentation has been done by the DenseNet, and then it has been classified into its specific disease or specific anomaly by unit, and then with the help of GradCam, you can even see where the actually anomaly is. So as I said, in the current researches, the research have been done extensively, but the only thing is the research have been done in a one single manner. So they haven't tried to, like, if I can say in this as well, the only thing which they have used is DenseNet. So DenseNet models, it's just segmentation, so which leads to a bit lower accuracy as compared, as you can see on the point number 1. The accuracy has reached around 0.76. And by our findings, we have find out by using this number of models and giving them a proper quality data after pre-processing, accuracy has reached a 0.87%, that is 87%, which is the current highest in this research. And these are all the researches which we find out, and these were the like the stepping stone for us, as we can see in this paper as well. The researcher has used unit for the classification, but there isn't any significant contribution of any other DL model. Similar goes for other cases as well. And the methodology which we have used, first is the data collection. As I said, we have used a data set of over 1 lakh images. And the second task was to do the data processing. As I said, it is related to a medical field. So the quality of the data should be our utmost priority. So the data processing, which I should say, it took the most of the time for us to research on this thing. Then I said to segmentation. Segmentation is basically, we did it with the help of DenseNet image segmentation. And then we used UNet as a classification technique. So what happened is, by this two layer of filtering, the accuracy is the highest in the current research. Then the model training with the help of CNN, and then the evaluation. And we have reached an evaluation of 87% on our testing data set. The 87% accuracy is on testing data set, and it has exceeded over 96 to 97% on the training data set. Actually, and we are currently providing it, and the accuracy, we are sure that accuracy even crossed 90%. And these are just the basic structure of how unit and DenseNet works. So this is like a filtering process which goes on through two different layers of filters. Then we are come to the final output. This is basically a visualization of how it happens. So what happens is, the model even learns to the previous data which we have fed. For example, if I have fed then 10 X-rays, it will evaluate the result of 10 X-rays and come up with the result to the 11th X-ray. So it is our complete model. And just to say, we are not saying that it will replace doctors, but we are trying to build a system which will help as a helping hand to our doctors, and which will lead to the such anomalies to zero. So thank you. That was my presentation. I am open to any questions. Hello. Hello.
Yeah, so there's a question for you in the chat box. Have you used data augmentation techniques for variability in the data set?
Yes, ma'am. Data augmentation has been used because the thing is, if I can just show, just a minute. Yeah, as I have mentioned here in the data set, what parameters have been used. So, for example, in x coordinates, y coordinates, the width and height of the image. So, it was a like a mandatory thing for us to use the data augmentation, and then with the help of that, like it was divided in n number of small portions. Then, the as I actually emphasized on, the most important was the pre-processing of the data, because in this field much data is not available in a specific portion, as I was focusing on chest and anomaly detection in lungs part of the body. So to have it and to have a really quality data so our models could train the best, it was a mandatory thing for us.
Ma'am, would you like to ask any other question? Okay, thank you, sir. We'll be proceeding on with the next paper presenter. I'd
Thank
like
you.
to call upon paper presenter Mandeep Kaur with a paper titled Automated IoT-based Multi-Level Parking Systems, a Technological Solution for Efficient Parking Management. Ma'am, if you're ready, then you may start with the presentation.
Am I audible?
Yes, ma'am, you're audible.
Thank you so much. Let me share my screen.
Sure, ma'am.
I hope it is visible.
Just a second, ma'am. Yes, ma'am, it is visible.
Let me have a slideshow. Good afternoon, everyone. My name is Dr. Mandeep Kaur, and I'm presenting my paper ID 1102, Automated IoT-based Multi-Level Parking System, that is a technological solution for efficient parking management. We, as in daily life, we go to market and we go to many places where we need to park our cars and our vehicles. So this particular solution, which I'm presenting, my author's name are already I've mentioned there on my PPT. So we have introduced a solution which is based on IoT, which is based on real-time monitoring, and the slot-based, which is the optimized one. The user can book their slots even before they have started started their journey from home or moving to the place. So this paper actually presents an IoT-based solution for the urban parking, which uses the ultrasonic sensors, Arduino Uno, and the cloud services, including it. So to start with, we have gone for the literature survey where we found that there are some challenges which we see, in the current scenario, also in the urban areas where the markets have been developed a lot, right? There is a multi-level parking, and this particular solution we have presented is open for the to be applicable for the multiple places, but we focused on the parking at our university. We have a multi-level parking area, this slot, a building complete of 8 floors. And there we found that people who are traveling, maybe far from 1 hour or 1.5 hours, they reach to the university and then they get the slot or they get the space of the parking, maybe at the 5th floor or the 8th floor. And maybe there is a problem with a old age employee or a student who is just a learner one. So that way, if someone can have an option of booking up a slot much a prior when he or she reaches to the university, that too at the lower floors, it can avoid that travel time to the upper floors and all. So through that literature survey and the challenges at our university also, we found that there are unavailable slots available to the people. There are long queues. Sometime when you reach to the prime time at the university, there are long queues to settle down in the parking. Then there are some payment issues if you go to the markets or the other places. Then finding the vehicle is very much difficult or a major challenge we found in the parking so we have proposed a solution which I told you is IoT based. The main components which we have used is sensors, the cameras, the the cloud computing, and for the data processing, some vehicle identification system is there, ultrasonic sensors are there, and we have also implemented a mobile application. Actually, this complete project is the, as I told you, it's a 8-floor project. So it is under the process, and it is we are in the working phase also. So we are also developing an application which is Python based, and there we are finding out. I'll let you know that what this web application does also. It has an add-on feature of finding out if there is a kind of event, major event which has been scheduled, like convocations or the orientation programs where some parents may come, and the traffic at a university may increase on a particular day. So that kind of information, how this application is going to get to know. So this mobile app is going to connect with the university application, university web app, or the university website. From there, it can collect the information of any major event which is coming up in the upcoming days, so that the slot based this parking can be efficiently used and it can be managed at the end of the user. So the system which consists of is the we have majorly 3 phases, but the starting one is the booking one, then the identification, then allocation of the vehicles in the parking slots, and then the vehicle when it exits. So I'll discuss the phase by phase implementation here. The first phase is the booking process. As I told you, this is majorly focusing on the university solution. So the faculty and the students are going to make use of this multi-level parking, and the visitors can also come up. As I told you, the parents can come up, or the other visitors, the delegates, they may come up in the university. They may be using the parking system. So first of all, everyone has to log in into the application which we will be giving it to the users. They may sign up, or they may log in using their student ID, using their faculty ID, or the visitors can give up their personal information, their name and email ID, mobile number, and other things. Once they are registered, then they may go on with the implementation of this, booking up of their slot, the respective slot which they look for, and the available slots which are there given up by the application, which is available there in the parking system as it is, will be shown to the user, and they may select it before even reaching to the university. So the implementation table, how it works, like the visitor who have entered, once it is entered, so that they may select the application. When they use it, they may select the duration, up to what time they will be reaching up to the university. They may book up the slots of the respective floors where they are available, and this information will be stored in our database, and the booking table is actually maintained. So this is going to help when a user who has already booked a slot before reaching to the university, whenever they will come up, this entry will be matched up with our database, and the respective slot will be open for that respective user. Second phase is the entry phase, where the number plate reader will be scanned at the entry gate. Of course, that number plate, because when I am an employee, my employee ID is not going to be changed. Of course, for a particular university, my car number is already there as a employee ID, that I am so and so with this car number. I am traveling every day to the university. So that is also being scanned. The system checks the booking table, because you have already pre-booked your slot. It is going to match. If it is going to match, obviously match is going to found, and you will be directed, and gate will be open to you, and the respective designated slot will be available for you. It will not be booked. Of course, it will not be filled up, and you may go and you may park your car there. So after the entry is there, thereafter, there's the exit phase, which says that once you have used up your parking slot, you are moving and leaving the university. So the number plate is also being scanned, so that whatever the slot which is going to be free, it may be used up by the other people who may be looking for the slot there in the parking system. So the daily record table is going to be updated at the exit time, as well as we have done it in the entry time. So it is going to make a kind of the solution where the occupancy of the slots are going to be manageable efficiently by the users who want to reach the university, even if they are late, but they want to use this slot, preferable slot where they can park the car conveniently. So as I told you, there is another add-on feature which we do have with the solution, not only the hardware but the software one also. So this is the webminer integration, where we are going to find out what kind of the events are going to be done in the university. At those events, traffic of the people and the car may be more at that time. So for the high impact events, it dynamically adjusts the parking slot durations, notify the users. So this application is not only the hardware based, it is software based. So you will be getting all the notifications on your mobile number through which you have registered on this web application and this particular application which we have proposed. The expected benefits is like, of course, the user experience. They are going to have hassle-free the parking slots. The pre-booking is also there. The time spent on searching the space is of course reduced, and security and finding out the where I parked my car and all those information can be easily found from this one. The operational efficiency also, it's real time, and it is automated entry exit processes, minimal intervention of the people who are required to give these slips. It is a paperless actually work. You need not to give a slip or the receipt of entering and exit the university or the premises of any market space and all. So environmental impact is also there. The traffic congestion, it can be reduced, and the public transportation promotion is also there, that the people, when there is a slot based application, the people are going to make use of this application. There is also, we find that we also expect our people to pool the cars to make use of the public transportation. But if in any case we are going to have those vehicles at our university, so it is going to be managed properly. They are not going to be any kind of the chaos at the university premises. So the information which we can retrieve it later on also, the daily usage patterns are there, the the peak parking periods. What is at peak time when our parking slots are highly used by the people, and there may be a kind of a queue may be maintained so that it can be more, the information can be analyzed more for the future also. So the what are the favored parking slots people actually go for, and various data driven informations that can be found on this one also. So the implementation results is like the 88.5% the problem which have been addressed of the users, that can be resolved. The navigation problem, it can be reduced. The queue reduction can be reduced, right? And the future enhancements also we are looking for, that if some kind of for the marketplaces, not for the university, that some automatic billing system, if it can be added on by us into this application, because we are going to we are also in the process of filing the patent to this solution. And once it is completely applicable, then we'll go for the grant also, and we will add on some features based on the commercial requirement of the market spaces. We are working, the backend team is also working on that. Our team is working on it, that the solution can be customized with respect to the requirement of that particular parking space wherever we are looking for to give the solution. So the conclusion is only that we are looking for a solution which avoids the papers, which avoids the which gives the users the hassle-free parking, and it is going to save their time, right? And efficiency is going to improve. The user satisfaction is also there. Yes, the most important challenge is the scalability. Though we will be looking for, the cost is not that much high, because we are looking for that the cost should not go higher at the end. So it can be minimized, and we are also in a plan of making it as a, through the 3D printers we do have. So we are going to make it as a box based hardware plus software, and the box based solution which can be implanted very easily at a particular parking slot in the parking areas. So with this, I hope that in future we are going to be there in the market with our solution, and the problem of the parking is going to be is solved. Thank you so very much for your time. If any questions you have.
Thank you, ma'am. There's a question from the session chair for you. Does the system work on day-to-day basis, or as a guest, I can book a parking slot for upcoming event half a week prior to the event?
It is day to day. See, I travel 1.5 hours from my university. So majorly I may face a problem where I have I have meetings on reaching my university. So if I'm going to park my car on the 8th floor, so it is going to be very difficult for me, though the lifts are there, but traveling and moving round and round to the respective floor is bit difficult for me. So it is day to day. I use it daily. I'm going to use it daily, because whenever I'm going to reach the university, the respective time must match up with you. There will be a time bound parking. So let's supposedly if I am starting my journey at 7:30 and I will be reaching by 9, but I, due to some traffic or some other problem, I'm reaching 10 o'clock. So that doesn't mean that my parking slot is booked for, the whole day. It is going to be time bound, and we are specific.
And ma'am, did you face any challenges during the implementation? Ma'am? It seems ma'am has some network issues, so we'll be proceeding on with the next paper presenter. I'd like to invite paper presenter Jaswinder Singh with the paper titled From Swamps to Speech, Nature-Inspired Algorithms and Automatic Speech Recognition. Sir, if you're ready, then you may start with your presentation.
Yes, ma'am.
Yeah.
Just give me 1 minute.
Sure, sir.
Is it visible?
Yes, sir, it is visible.
A very good afternoon to all of you. I am Jaswinder Singh from DAV College, Hoshiarpur, Punjab, and I am honored to be here today at the 10th edition of the International Conference on ICT for Sustainable Development. I'm going to present on a topic that blends the elegance of nature with the power of computation, from swarms to speech, in nature-inspired algorithms in automatic speech recognition. This presentation explores how behaviors observed in nature can inspire powerful solutions in speech recognition technology, enabling more sustainable, efficient, and intelligent human-computer interaction. In this presentation, I'll be covering the following key topics. Firstly, introduction for setting the context and significance of the research, then literature review. Next, the details about the nature-inspired optimization algorithms, then an overview of automatic speech recognition systems and their core components. Next, the integration of nature-inspired optimization in ASR and highlighting how these algorithms are applied to optimize and enhance speech recognition systems. Then summarizing the key findings and potential research directions. And lastly, listing the reference resources that support this work. So let's start with introducing the topic. Optimization is crucial in science, engineering, and management, especially for complex or constraint problems. Nature-inspired optimization algorithms solve such problems by mimicking natural processes. Examples like genetic algorithms, particle swarm optimization, and simulated annealing. They outperform traditional methods in high-dimensional, noisy, and nonlinear problem spaces. In automatic speech recognition, these algorithms are used to improve various aspects of ASR, as discussed further in this presentation. Several studies have demonstrated the effectiveness of nature-inspired optimization algorithms across different domains. They have been applied successfully in engineering design, logistics, image processing, and financial modeling, as shown in works by Goldberg, Dorigo, Zhang, and others. Key techniques include genetic algorithms, PSO, ACO, and simulated annealing, each suited to different type of optimization problems. Genetic algorithms help with feature selection, PSO improves hyperparameter tuning, and ACO has been used for refining language models. Hybrid approaches combining these methods with deep learning have also shown improved robustness, especially in noisy environments. So, few words about these algorithms. Nature-inspired optimization algorithms are computational approaches that mimic natural process to solve complex optimization problems. These algorithms are effective for complex NP-hard problems where traditional methods fall short. They fall into four main types: evolutionary, that mimic natural evolution; swarm intelligence, that are inspired by collective animal behavior; physics chemistry based, that rely on physical laws and chemical processes; and various other nature inspired algorithms derived from ecological and social systems. All these algorithms are popular due to global searchability and minimal need for problem specific designs. These are specific nature-inspired optimization algorithms that have been developed over the years, thoughtfully categorized based on their natural behavior or phenomena they emulate, from evolutionary processes and collective swarm intelligence to physical and chemical systems. Each category reflects a unique source of inspiration used to solve complex optimization problems. This slide presents the core components of an automatic speech recognition or ASR system. ASR is the process of converting spoken language into written text, and its foundation behind voice assistants, transcription tools, and many interactive technologies we use today. First of all, feature selection and extraction transforms raw audio into meaningful data using techniques like MFCC and spectrograms. Acoustic modeling maps these features to linguistic units like phonemes. Then language modeling predicts the most likely sequence of words, helping the system understand confusion between similar sounding words. Hyperparameter tuning optimizes settings like learning rate and network architecture to improve performance. Then speaker adaptation customizes the system to individual voices, improving accuracy for different speakers using techniques like speaker embedding or fine tuning. Then noise robustness is crucial for real world use, where we have to remove the noises. Pronunciation modeling addresses variations in how words are spoken. Deep learning model training is the backbone of modern ASR with architectures like CNN and RNN. And finally, real-time processing ensures that ASR works instantly, critical for live captioning and voice assistance, as you can see in YouTube. Then next we have the implementation of ASR into NOIs. This slide focuses on the early stages of ASR pipeline, feature engineering, and acoustic modeling optimization. Nature-inspired algorithms like particle swarm optimization and the Firefly algorithms are used here to improve how audio data is presented. These algorithms help in identifying the most informative features while avoiding redundant ones. In the acoustic modeling, genetic algorithms and differential evolution are used to evolve model parameters. These help in improving the mapping between phonemes and actual sounds. Next, moving on to the middle layer of ASR, language modeling and hyperparameter tuning. For language models, ant cloning optimization and harmony search have shown promise in finding optimal word sequences. They leverage probabilistic paths and contextual harmony to improve sequence prediction. In the hyperparameter tuning space, simulated annealing and memtic algorithms provide systematic exploration of parametric space. These algorithms enhance model performance by refining learning rates, batch size, and architecture-specific settings. Finally, we address advanced and adaptive areas of ASR, personalization, robustness, and deep learning training. Speaker adaptation benefits from genetic programming and artificial bee colony methods, which have built models tailored to individual speakers. These are critical for real-world applications, but speaker variability and data sparsity can make training unstable. For improving robustness to noise, gravitational search and cuckoo search algorithms are applied. They fine-tune parameters for noise filtering, improving ASR performance in real-world environments. Pronunciation modeling and deep learning training also see gains from evolution strategies like ant cloning optimization and Firefly algorithm. These optimize both model convergence and pronunciation variation handling. However, the resource cost both in data and computation is significant, which poses scalability issues. So moving on to conclusion, to conclude, nature-inspired optimization algorithms offer a compelling paradigm for advancing automatic speech recognition. As we have seen across the previous slides, these algorithms effectively address a variety of ASR challenges, from optimizing feature selection to enhancing noise robustness and personalizing models for individual speakers. So the key takeaways are clear. First, these algorithms significantly enhance both the accuracy and robustness of ASR systems. Secondly, the diversity of algorithms allow us to tackle highly specific challenges within the ASR pipeline. And thirdly, hybrid approach combining different nature-inspired strategies or integrating them with deep learning show considerable performance for future improvements. Looking ahead, my future work will focus on 4 major directions: developing more efficient algorithms suitable for real-time ASR applications, as you usually see in YouTube. Then designing novel hybrid architectures that combine these algorithms with deep learning for more powerful modeling capabilities. addressing the scalability and computational cost limitations that currently hinder wider adoption, and finally, improving generalization across diverse languages and speaker accents to ensure inclusivity and broader applicability. So these are the giants on whose shoulders we have stood to build our research. Thank you very much. Any questions?
So there's a question for you from the session chair. Have you used any data set for training the model, or have you used a pre-trained model?
Actually, ma'am, this is a exploratory study. We have studied various research papers, and we have a little bit practical thing right now in Kaldi pipeline. These are very, interesting algorithms. So currently, we are in the process of collecting data from almost 35 speakers. We have already collected 2,000 sentences spoken by different persons like old people, children, and young age people. And we are trying to implement these algorithms in the Kaldi pipeline, and soon we have some good results.
And what are the sources have you explored for data collection?
Actually, ma'am, for data collection, we have, contacted with various schools and colleges in the area, from where we have collected voice samples of students as well as teachers as well as some old people, and we have, as I already told, we have collected a data set of around 2,000 spoken sentences, and we are implementing these in the Kaldi pipeline.
Okay, thank you, sir. We'll be proceeding on with the next paper presentation.
Thank you.
I'd like to call upon Achal Seni with the paper titled More Than Skills, How Digital Competence and Partner Attitudes Shape Financial Resilience in Couples. Ma'am, if you're ready, then you may start with the presentation. Ma'am Achal Seni? Seems we do not have her in the meeting yet. We'll be proceeding on with the next paper presentation. Kaushik Sakre with the paper titled Multilingual and Automated Essay Scoring with Transformer Models. So if you're ready, then you may start with the presentation.
Hello, am I audible?
Yes. Yes, sir, you're audible.
Yes, sir. Let me share.
Sure, sir.
Is it visible?
Yes, sir, it is visible.
So, good afternoon, everyone. I am Kaushik Sakri, and I am excited to present our paper titled Multilingual Automated Essay Scoring with Transformer Models. This project is a joint effort with my colleagues, Ms. Rasika Ransing, Ms. Neha Kadu, Mr. Shivam Shinde, and Ms. Siddhi Talkar. And we are honored to present it here at ICT4SD 2025. So, to give a quick roadmap, I will begin with background and motivation behind our work, then cover what the exciting existing literature is, followed by our research objectives, how we build a system, the results we observe, and finally, where this work can go in the future. Introduction. So, why do we choose to work on assess scoring? Well, automated assess scoring has been around for a while, but almost all tools focus on English. In a country like India, where many students study in Hindi and Marathi or other regional languages, this creates a big gap. And manual grading isn't just slow; it's also subjective. Different teachers might score the same essay very differently. So we wanted to solve both these problems by building a system that uses AI and transformer models to score essays with multiple languages automatically, fairly, and at scale. Literature review. We review past work to understand how essay scoring has evolved. Earlier, the systems like HAES used XLM Robota for Hindi but were limited by dataset size. Some like AOES models focused on scoring and off-topic detection, which was great but harder to interpret. Others like Skipflow LSTM worked on coherence but had design complexity. Recent studies using Robota and Distilbert improved scoring but required a lot of labeled data. One standout was BERT-based AES for scientific writing, which handled technical terms well, but wasn't scalable. What we observed is that while performance has improved, most models are designed for English. Very few focus on Indian languages. To to sum it up, there has been a clear shift from manual coded features to deep learning models. Transformer-based models like XLM Robota and Mbert are being used widely, but very few models work across multiple languages, especially regional ones. And most systems focus only on giving score, and then they don't explain why or offer feedback. So main objective with that gap in mind, we set three clear goals. First, to build a model that can score English, Hindi, Marathi essays accurately. Second, to reduce the time and effort of teachers to spend on grading. And third, to make the system fair so students from different language backgrounds are evaluated equally. Methodology, we began with public dataset from Kaggle competition over a 17,000 English essay. So for Marathi and Hindi essays, we translated them into particular digital languages using Google Cloud Translator to ensure consistency. We manually evaluated some samples. Uh, then we trained four popular transformer models: XLM Robota, Muriel, Tailbot, and Ambert. To evaluate this model, we didn't use normal accuracy metrics. We measured using QWK score, RMSE, and R2, which I will explain next. So here is the bar graph presentation for QWK score comparison. Uh, so the QWK score measures how closely our model score match those of human raters. Here, XLM Robota performed the best, followed by Mural. On the other hand, Mbert and Distilbert struggled, especially with Hindi and Marathi languages. Then next for RMSE score comparison, which RMSE stands for root mean square error. It simply tells us how far of the model's prediction are from the true score. So lower is better. Again, XLM Robota and Mural did well here, but Mbert had a higher error rate, especially in Marathi. So then R2 score comparison. Here, Muril performed especially well on this matrix, giving us confidence in its understanding of language pattern. Then here is the graph for training versus validation loss for Muriel and XLM Robota. Uh, you will notice that both Muriel and XLM Robota, the loss curve goes down smoothly, meaning they are learning efficiently. Then this is the table for Muriel performance and XLM Robota performance. Uh, the table for Google Mail parameter tuning and Self Robota parameter tuning. So we changed the batch size and learning rate to for hyperparameter tuning, and the best parameters recorded were the batch size for 8, epochs 6, and learning rate 2e minus 5. And we also added cosine learning rate scheduler to make the learning more stable. So these are this is the conclusion for research and discussion. The best models were XLM Robota, PWT score 0.78 and Neural 0.77. Poor performance was recorded from Ambert and Distilbert in Marathi and Hindi. Lowest for RMSE was lowest for XLM and Neural, highest for Ambert in Marathi. Neural R2 score for Neural was highest in all the three languages. Optimal parameter was the batch size 8, learning rate. to E minus 5 epochs equals to 6. In conclusion, we successfully developed an automated research scoring that works across English, Hindi, and Marathi. Our top models were excellent robot and Mural showed strong performance in terms of scoring, accuracy, and journalizing and fairness. In this multilingual approach makes assess grading more inclusive and could help bridge assessment gap across Indian classrooms. However, there is room to improve, like better handling of cultural nuisance, idioms, and offering more meaningful feedback. Features we see a huge potential going forward. We can fine tune your transformer models by increasing the dataset size or creating a more authenticated dataset, improve automatic expressions, understanding, then long-term goal to deploy this in a mobile apps and online exam platforms, making it useful for both students and educators. Thank you.
So there's a question for you from a session chair. Are you planning to train the model with a larger data set for a better accuracy?
Uh, yes.
Okay. Ma'am,
So,
would you like
Bulk,
to ask?
this
Yeah,
this
sir.
this model was trained on total of 52,000 essays, each 17,000 for English 17,000, Hindi 17,000, and Marathi 17,000.
So ma'am says running it for more epochs than 6 epochs improve the accuracy.
We no ma'am. We tried for 10 epochs also, but the model was overfitting as the training loss was increasing after certain epochs.
Okay, sir. Thank you. We'll be proceeding on with the next paper presenter. I'd like to call paper presenter Tarun Kurakula with the paper titled Network Anomaly Detection Using Graph Embedding. Sir, if you're ready, then you may start with the presentation.
Yeah, am I audible?
Yes, sir, you're audible.
Thank you. My screen is visible, right?
Yes, sir.
Okay, so good afternoon, everyone. I am pleased to present our research work titled Network Anomaly Detection Using Graph Embedding, paper ID 1145, along with my co-authors. And this research paper is affiliated with the SIS Graduate School of Technology. Moving further, as networks grow in size and complexity, so do the methods by the attackers. Traditional signature often struggle to identify the novel or stealthy threats. Our research explores how graph embedding techniques commonly used in social networks and NLP can be leveraged to model network behavior and detect anomalies in a scalable and adaptive manner. Moving forward, our objectives is to first to transform a high dimensional network traffic data into a low-dimensional embeddings. Second, to accurately detect node, edge, and subgraph anomaly levels. And third, to ensure approach is scalable to large and dynamic networks. In this embedding technique, we have specially used GAT, which is a graph attention networks. And further, I'll let you know more about on this. These are some of the existing systems which are currently present. First, as we all know, Microsoft Defender, and which uses a graph-based modeling to track behavior across endpoints. And the other are dark trace endpoints. Various model, but none of them uses a GAT, which is graph attention network. Other existing works which are currently present is GCN based on IDS, which uses graph convolution networks. These are from the academic researches. And moving further, these are our literature survey, which we took a thorough reading of it and try to implement what are the limitations of there and the findings. Most of them have used GCN, SVM, and other networks to create a graph embedding of the system. Moving further, we have tried to keep our methodology very simple, as we have focused more on the model, which is our GAT model. So we have deployed it on a Streamlit application for the interface. And for the data source, the user have two options. Either he can upload a real-time data set, or he can use a default dataset, which is UNSW NV15 dataset, which is a used dataset. And by the real-time data, I mean the Windows current logs, Windows registry, or if a person is using Linux, it can be uploaded. And after that, we pre-process our data, we clean it, we normalize and standardize the network traffic data. And then there is this graph construction, which is our main building block at the start. By creating a first order graph, which shows a direct relationships, and a second order graph, indirect or multi-hop relationships. These two graph generation will help us further for our model, which will work as an input to our model. Moving further, graph feature extraction. Our GAT model, GAT, extracts any hidden points or any weightages it has been given, and it to take it as an input and try to analyze anomalies. It detects various anomaly and simulates various types of attacks which has been used on the network. This is our proposed system, by which we at the beginning we have used, as I said, Streamlit application, and then by prepping the data we have used various types of Python libraries. And as we go forward, we build graphs with the cosine similarity is in first order graph and second order graph. Then these graphs act as an input to our GAT model. And after GAT analyzes, it checks for anomalies, and there are various pre-constraint which we have already put, I would say, like a rules. We have already defined it in our model, and further it can be modified. This model is like a supervised learning model. So it learns from the previous and it can create its own rules based on it. At the start, we have put our rules, some of the rules, and currently model is running exactly very fine. By moving further, the results, and we have achieved a high accuracy and area of curve by transferring learning models, and limitations is only that it depends on the dataset quality, further tuning needed for the real world deployment. This is the result that I have shown you, first order graph and the second order graph. As you can see, first order graph, there are direct links connected with each other, and in second order there are hidden connections between each nodes. Moving further, these are the anomalies detected by our GAT. So the major difference between a GCN and our model GAT is that GCN does not give enough weightage to its neighboring nodes. It gives equal markings and treat all neighbors as equals. But whereas in GAT, it uses a graph attention network. So it means it gives weightage to our network systems and each node. So these are the anomalies detected by our system. There are various anomaly flags at the right side, as you can see, HTTP potential loss, suspicious port, and these are our evaluation metrics. And we have achieved an accuracy of 95%, as you can see, and precision of 92%. These are several demonstrations of the attacks and the attack simulation that we have done. Various HTTP potential DNS. These are the attacks which mostly occur at any organization or a high-tech organization. Applications, there are various applications. As I said, this model is just a first step in a GAT. This it can be used in insider threat detection, phishing and spam detection, traffic classification, and botnet detection. It can be used in intrusion detection system, as this would play an advanced part of a traditional IDS systems. Conclusion, I would like to say published demonstrate that graph embedding combined with the GAT is a powerful tool for network anomaly detection with latency of below 500 milliseconds. It is suitable for real-time use also. Our hybrid modules reduces false positives by over 30% and scales efficiently to over 10,000 nodes using datasets like UNSW NB15. In future work, we plan to explore temporal GNNs and integrate dynamic graph learning to improve adaptability and robustness in our real deployments. These are our references that we have learned and try to implement in our systems. Thank you so much, and I'm open for any further questions if there are.
So this
Hello?
is a question for you
Yeah.
from the session chair. Does this
Yeah.
system handle any malware attack? Like, can it handle any malware attack?
Yeah, it can identify a malware attack with if the attacker is in a network system. So it can track efficiently on which IP address the attacker is and from which source and destination IP the malware is being sent to. So at that point, we can trace the hacker and we could mediate it immediately.
Okay, so thank you. We'll be proceeding with our next presenter. I'd like to
Thank you.
call upon next presenter, Jay Sutar, with the paper title Recommendation System for INR Bonds. So if you're ready, then you may start with the presentation. Sir Jay Sutar. It seems we do not have him in the meeting yet, so we'll be proceeding with the next presenter. Aisha Nagdawala with the paper title Shade, a blockchain-based anonymous tip-off system for secure and verifiable reporting. Ma'am, if you're ready, then you may start with the presentation. Ma'am Aisha?
Yes.
Yeah.
So, good afternoon, everyone. I am Aisha Nagdawala, and I am here to present a paper, and it is titled Shade, a blockchain-based anonymous tip-off system for secure and verifiable reporting. Our paper ID is 1019, and here's the agenda for the presentation. So, we'll begin with the problem statement and then the background. We'll look into the existing literature and the proposed methodology. And then finally, we'll discuss the results and the future scope. So according to the National Crime Victimization Survey that was conducted in the year 2023, as many as 4 in 10 people did not report crimes. And this was mainly because they were scared that their identities will get revealed. And therefore, they'll be exposed to any sort of retaliation and threats from the criminals. So our goal was simple. It was to build a secure, anonymous, and tamper-proof tip-off system. It used modern technologies like blockchain to encourage safer reporting. And we will also ensure that the communication is encrypted so that the criminals are not alerted that the crimes have been reported. Because we know that blockchain is transparent and everything is visible. So we didn't want to alert the criminals. So the traditional reporting methods like phone calls, emails, or web portals, they all have their own limitations. So they will either compromise the anonymity or they are vulnerable to any sort of tampering. And mobile apps, even though they are convenient, they will usually require identity verification. And this will discourage the user because it would give away their identities. We also looked at some advanced solutions. So VPNs, virtual private networks, even though they provide anonymity, they will not really guarantee the authenticity of the data or the genuineness of the tip. Whereas blockchain will offer immutable data records and it will ensure transparency and integrity. So so before building our solution, we checked if there exists any solution. So these three were the closest. So there's something called as a National Cybercrime Reporting Portal. However, it will only focus on the cyber crimes. Then we have the Bharosa Cell, and Bharosa Cell will only focus on the crime that is related to women and children. Also, it is not just, it's not really a reporting platform, rather, it is more on the support side. Lastly, VTip. It is closer to our goal. However, it did not really verify how genuine the tip by the tipster was, and it did not really provide any rewards or incentive to the tipster. So our proposed system Shade will combine three key technologies: blockchain for the secure and tamper-proof records, ML algorithm for checking the genuineness of the tip, and lastly, encryption to ensure that only the police authorities can view these tips. So let's look into the flowchart. So the first step is that the user will have to create a MetaMask wallet and log into it. So it is very easy to create a MetaMask wallet. It is a browser extension. And one of the reasons we use a MetaMask wallet is because it doesn't really require any personal identifiers. Like usually when you log in or when you create anything new, you need your phone number or maybe an email address or your name. MetaMask doesn't really require anything of that sort. So this will ensure there's a complete anonymity for the user, and each user will be represented using the wallet address of their MetaMask. Now, once the wallet is set up, the user will log in and they are presented with a form to submit the tip. So the form will look something like this. There is a section for the user to enter a detailed tip, and this is where the user will provide all the relevant information about the issue that they are reporting. Next slot is optional, however, it is important. So here the user can upload any supporting evidence or documents that they might have had, and they can enter any multimedia like images, videos, audios, etc. Next, the user is asked to mention the location where the crime had taken place or the crime will take place. Now, after the user clicks on the submit button, we don't immediately push the data on the blockchain. Instead, we first verify the genuineness of the tip. So, for example, if the user has entered something absurd, like I will steal the moon tonight. So it is logical that such tips are fake. So for that, we have an ML-based genuineness checker, which will evaluate the content of the tip. And it will automatically reject this tip and not push it onto the system. And this in turn will save the time of the authorities. Next, we will also check if the user has previously been blocked by the authorities because they must have entered the fake tip in the past. Now, let's say if the tip was genuine and the user was also not blocked, then we will move on to handling any attachments that the user had previously submitted. So these attachments will be uploaded to IPFS. Now, IPFS stands for Interplanetary File System, and it is a decentralized peer-to-peer file storage protocol. So unlike the traditional cloud storage, IPFS will not rely on a central server, and it works by splitting the file into chunks. Now, each of these chunks will get cryptographically hashed, and then this hash then gets distributed across a global network of the nodes. Now, once the multimedia attachments are uploaded of the IPFS, we will receive a corresponding CID for each of these files. So CID stands for Content Identifier, and it is a unique hash value for each attachment. And if there is any change in any of these multimedia, it will significantly affect the CID of that particular attachment. Now, after we receive the CID, we will encrypt both the particular tip and the CID, and this will be done using the public key of the authority. For this, we have used RSA of 1048 bits. And this can ensure that only the authority with the matching private key can decrypt, and therefore only the authority will be able to view the content of the tip and its attachment. So this will add another extra layer of confidentiality and security. Now, finally, this encrypted version of the tip and the CID is uploaded to the blockchain, making it tamper-proof, immutable, and traceable while still preserving the user's anonymity. Now, once everything is ready to be pushed onto the blockchain, the user will receive a sort of transaction request on their MetaMask wallet. and the user will have to make a small nominal gas fee payment or transaction. So it is not really a loss to the user. If the tip that was submitted by the user turned out to be genuine and helpful, the authorities will anyway reward them. So now that we've seen the process from the tipster's side, let's see what happens on the authority side. So the authority will log in using their username, password, and their particular location. So in the backend, we'll have two operations that will take place. First, the system will only retrieve those tips which are matching the location that was entered by the authority. So the authority will only see tips that is relevant to their particular jurisdiction and save their time. Second, like we said, we had encrypted the tip and the CID. So here the decryption with the private key of the authority will take place. And finally, we'll see the decrypted version of the tips and the supported documents on a secure dashboard. So this is what the dashboard for the authority will look like. So it will have the location, which is Mumbai in this case, the date and time when the tip was submitted, the particular tip, and any supporting documents. Lastly, it will also have the submitter's wallet address, which will be used to either block their particular wallet or send rewards. So once the authority will receive the particular tip, they will review this information, they will perform investigation, and if the crime has been prevented and it was a legit tip, they can send a reward to the particular tipster. However, if the investigation concludes that the tip was fake, then the authority can simply choose to block this particular user. So this will help prevent the tipster from submitting further tips in the future, and overall it will help maintain the integrity of the system. So this is what our data set look like. This is a small snippet out of it. So we had the description and we had the labels, genuine and fake. So to summarize this, we have implemented a secure and anonymous crime reporting system. It will encourage the citizen participation, and it will also increase the trust between the tipsters, the citizens, and the law enforcement. We have used blockchain technology, ML, and encryption. And for future scope, we were planning that we could compare the textual description of the particular tip with the attached multimedia. So we were trying to see that if the particular multimedia is matching the particular tip, then the chances of that tip being genuine becomes higher. And we wanted to work alongside the ML model for more reliable verification. That's it. So any questions?
There's a question for you from the session chair. Any ethical concerns on misuses of this application you have thought of?
Ethical concerns, as in anything in particular?
One second. Session chair says that it's a good idea, but it requires strong verification and security.
Yes, so the point was that usually people get scared to report any crimes because of the whole anonymity. And the goal was to prevent the identity of the user. And our major issue was to ensure that the authorities' time is not wasted behind fake tips. That's why we added the block system. And yes, the system does deal with sensitive crime-related data. So we had to ensure anonymity of the tipster is fully protected, both technically and ethically. And we couldn't find, for the same reason, we couldn't find a data set for the same. So we had to synthetically generate it. And by going through previously reported crimes and newspapers online.
Okay, thank you, ma'am. We'll be proceeding on with the next paper presentation. I'd like to call upon paper presenter Suhash Bhije with the paper titled Statistical and Machine Learning Approach for Time Series Forecasting in Industrial Edge Computing Environments.
Yeah,
Sir, if you're ready, then you may start.
yes, we'll start.
Yeah.
Uh, Is my screen visible?
Yes, sir, it is visible.
Okay. So there is a growing deployment of IoT and the mobile devices into the market, and because is visible screen.
Yes, sir, it is visible.
Just to see. Yeah. So there is a huge amount of data is available in the market, and because of that, also along with that data, the high velocity time series are available. So this paper is supposed to investigate the forecasting approaches for the time series data in the industrial age computing environments. So this paper compares the statistical methods like the simple moving average, Holt Winters, ARIMA, and machine learning models like the logistic regression and XGBoost. And based on that comparison and execution of the programs, the findings are there that there are some lightweight models like the XGBoost, which are the much more viable for forecasting in the edge computing environment. So initially, there's the cloud and the cloud computing scenario, which offers a lot of scalable resources. But there's a issue of the latency, bandwidth, and the energy when we consider the real-time IoT application. So along with that, there are challenges like the bandwidth consumptions for the transmitting data, energy consumptions, and the privacy concerns are more with respect to the cloud. So there is an involvement of the edge computing scenario, and that edge computing scenario is going to do the computation much closer to the data sources. So ultimately, it reduces the latency and the response is also improved. But when we have to implement this, that time it's necessary to have the lightweight models with the less computational requirements at the edge so that the time series data can be effectively used and the forecasting can be done. So there are these three statistical methods are used, models are used like the simple moving average, which is a baseline model for the time series prediction. And its purpose is to smooth the noise and do some predictions based on that summations of the all the values. Or it takes the past observations, does the summations and give us the prediction. There are some limitations of the simple moving average. So Holt-Winters exponential smoothing is used, which is based on the exponential scenario smoothing technique for the forecasting purpose. Both are having limitations. So a powerful statistical model is used for the forecasting, and that is the autoregressive integrated moving average model. So these three statistical models are considered for forecasting of the time series data in the industrial age environment. So along with these statistical models, machine learning models like the logistic regression and the gradient descent, logistic regression with the synthetic minority oversampling techniques, and the XGBoost are considered. Logistic regression is actually a classification algorithm, but that can be used much more effectively in case of forecasting if it is used for predicting as a binary class. So slightly twisted approach is implemented here. And the sensitivity of that logistic regression is not that much. So to improve that sensitivity, the synthetic minority oversampling techniques combined with the logistic regression, some results has to be obtained. There's the extreme gradient boosting, which is efficient, flexible, and portable machine learning library that can be used for the time series forecasting, which works based on the creation of the trees and which is effective trees. Based on that, it does the forecast. So three statistical models and three machine learning models are considered for the experimentation purpose. We had a platform of the Google Colab with the Python 3.10. The database used is the Microsoft Azure database, and that database is there in the predictive domain in the industrial environment, which has instances of 8,70,100 instances. Data values are there, and all those instances are in a structured manner, and the permissions are public, so we are able to use it very effectively. Now, if I see the dimensions of this data set, then it is 8,76,100 multiplied by the 6 columns, and those 6 columns are with respect to the telemetry maintenance machines values and the errors. The space occupancy by this data set is around 60 MB, and it contains the 100 machines data which is taken hourly for the entire year with respect to the parameters like voltage, rotation, pressure, and the vibrations. So this data set is obtained from the Kaggle, which is available in a public domain, and that is used on the platform of the Google Colab. If I see that, if we try to visualize the data, then there's parameters like vibration, pressures, rotations, voltage are for entire year, like the time series data. Now that time series data has to be checked whether the data or the time series is stationary, and behavior of that time series data is normal or not. So augmented Dickey-Fuller test is used, and that time the null hypothesis is considered as this time series is not the stationary. After doing the stationarity test, we found that the probability value is 7.9 into 10 raised to minus 23, which is very less than 0.05, which substantially rejects the null hypothesis, and it gives us the information that this time series is the stationary. There are some outliers in this data set. Those outliers are also removed based on the z-score. If the value of the z-score is greater than 3, then the outliers are removed, and then normality test is considered. The normality histogram is seen here, and in this histogram, the normal behavior is there, but there is a small skew on right hand side, but that is not going to affect too much in the forecasting. And after that, once this data set is there, time series data, I have to check whether that data is having sufficient information or not, and that I can be checking out with the calculation of entropy. Now, if I have a higher entropy, then it says that there is a good, the entire time series is stable, and there is a good amount of information is available in the time series data. So in the graphs, if I see that the entropy calculations for the voltage, pressures, rotations is above 2.5, so that time series contains a good amount of data. Now, if the time series has a data, I have to check whether that time series I can apply to the forecasting model, and for that case, I have to find it out the Hurst exponent. Now, here in this figure, it shows that for the time series data of vibration, I had the voltage I calculated, and it says that the Hurst exponent is greater than 0.5, which indicates that there is a persistent data is available. So I'll be able to easily apply to the forecasting models like ARIMA also, or the exponential smoothing average methods, or also I can be able to apply it to the LSTM deep learning methods like the LSTM. So everything is now on the line, so I'll be applying those time series data to the simple moving average. So initially there will be training and the testing phase for the simple moving average, and when I do that, uh, the upper figure indicates that there is good correlation, but there is a deviation from the peak values, and that is confirmed with the error metric like the mean absolute error, and which is 10.63. So there is a deviation from the original values with this training and tested values by 10.63 units. If I see the mean square error from the upper figure, it is around 177, which is large, whereas the mean absolute percentage error is 6.30, which indicates that this training testing evaluation is good, and generally it is acceptable if it is the MAP is less than 10%, so it is 6.3%, it is there. Now, the bias seems to be 0.0, which indicates that there is no over-prediction or the under-prediction is going to happen. So the result is going to be good. And then after checking this error metrics, the forecasted values is calculated for the next 50 values, and which is shown in this right hand side bottom figure. So it sees that initially the behavior, though the magnitude is less, but the behavior is similar to the time series data. But after that, it converges to a flat line, which is a concern in the simple moving average. So there is a thought to go for the exponential smoothing average, and that exponential smoothing average compared to the previous simple moving average, where the mean absolute error is 10.63, whereas it is mean absolute error is increased by 12.32, which is also can be seen through the figure where the larger deviation
Excuse me,
is.
sir.
Yeah,
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
yeah, okay.
Yeah.
So this exponential smoothing is also there, but there is a seasonality is observed. After that, the ARIMA is implemented, and that ARIMA also shows that the forecasted result with the seasonality and the trend. So there is a movement towards the XGBoost prediction, and XGBoost prediction, if I compare with the bottom, which is the ARIMA result, it is going to give me a good similar to the original time series data, and the fluctuations of the data is also good. So XGBoost prediction result is comparatively much better with the ARIMA and the other techniques. So based on this discussion, the simple and the ARIMA both have the lower mean square error than the exponential smoothing, but their performance is that much not good. Logistic regression, I didn't show the result, but that logistic regression is not that much effective for the time series forecasting. So ultimately, we need to move to the XGBoost, and XGBoost provided the better result compared to the ARIMA, which is shown in the figures. And then it seems to be more effective technique for the age-based forecasting. So in the future scope, this statistical and the machine learning models can be combined with the hidden Markov model, and based on that, some forecasting can be done. Also, it will be possible to have the deep learning algorithms, and those deep learning algorithms like LSTM or the GRU can be used. So this can be effective in case of the improvement of the quality of service parameters. So thank you for questions.
Thank you, sir. We have a question for you from the session chair. What are the data pre-processing techniques you have used?
Already at data pre-processing, first I check whether there is not a numbers. After that, there's the outliers. So these basic pre-processing techniques we implemented.
And does random forest algorithm work for this technique?
Uh, we didn't check it out, the random forest algorithm. We went directly to the XGBoost. But we'll think that we should check it out with the random forest algorithm, see how the results will be there. So we need to compare that. We didn't check it out with this data set for the time series.
Okay, sir.
Yeah.
Thank you,
ma'am.
sir. I'd once again like to call out for Jay Sutar or Achal Saini, ma'am. And sir, if you're here, then you may start with the presentation. It seems we do not have them in the session, so that brings us to the closing. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair for chairing the session. A token to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.